Hi Megan, this is Mr. Karmali. I'm trying to make this video while I'm sitting in an armchair and doing the problem you sent me. So bear with me. I don't know whether you can hear or not, but I believe the problem you sent me was x to the fourth minus 3x squared plus 2x was a function. Okay, and then the prof expects you to fill in this table that you sent me. So let's just kind of do it step at a time. So this one is x to the fourth minus 3x squared plus 2x. The derivative is excuse me, 4x cubed minus 6x plus 2. And the second derivative is 12x minus 6. And so the domain, you know, is all real numbers because this is a polynomial. So domain is minus infinity to infinity. Vertical asymptote, well, it's just a straight polynomial, so there are no vertical asymptotes. Again, it's a polynomial, so no horizontal asymptotes. These happen only when you've got something like a polynomial, like, remember, I don't know if you remember px over qx stuff. And so the vertical asymptotes come from the denominator of this bottom thingy. Horizontal asymptotes happen based on the degrees of the top and the bottom. And I think we did this in pre-calc and calc, so you might be able to find some notes somewhere, or go on my go on my website and look up those videos on that. So what is the sign analysis for I can't read this for f prime and f double prime. Okay, so what does this mean? This really means that he wants you to take 4x cubed minus 6x plus 2 and set it equal to 0. So let's do the first derivative first, okay? If I divide by 2, I get 2x cubed minus 3x plus 1 equals 0. Oops, daisy. So that means that if you look here, I think you can see that f of 1, oops, what's happening here? I don't know. F of 1 is equal to 2 minus 3 plus 1 equals 0. And so x equals 1 is a solution. Then there are other solutions, but you'll have to get them by doing synthetic division. I don't know how much of that you remember. So that's 2, 0, negative 3, 1. And you're going to put 1 here and do synthetic division. So you get 2. That's a 2. That's a 2. That's a 2. It's a minus 1. And it's a 1 that gives you a 0, which you should get if x equals 1 is a 0, okay? Which means now that you've got a quadratic, 2x squared plus 2x minus 1 equals 0. This might be factorable as well. I don't know. Let's take a look. That's 2x. Is it factorable? No, it's not factorable. Which means you've got to use the quadratic formula for that. So x equals minus 2 plus or minus square root of b squared, which is 4 minus 4 is c, which is 8 all over 2. And you work this out, okay? And whatever you get minus 2 plus or minus, that's 12. So that's 3 root 2 over 2. And it becomes minus 1 plus or minus, minus 2 plus or minus 3 root 2 over 2. So some funky numbers, okay? So what he expects you to do there is to put things, so you need to fill this, see how he's got a number line in here? So you got to put things in a number line. So first of all, the most important number on the number line is a 0, because Indians discovered it, aha. And then your other ones, what did we say, 1, so here's 1. Then you got another 2 coming out of here, and right now I don't know where they would be. I know that minus 2 minus 3 root 2 is going to be a negative number, so that's going to be somewhere out here. And then minus 2 plus 3 root 2 over 2. I don't know. I mean, use your calculator. I don't know if it lets you use that or not. But that's going to be 1.4. That's 0.7. That's 2.1. I think it's somewhere out here. Okay. And then what you do is what you've got is your f prime of x is equal to, and he's giving you some nasty things here, okay? I mean, the numbers are not really nice unless I've effed up on my factoring and all that stuff. So what you want to do is you really want to analyze this function for its being positive and negative. Because remember, positive, negative will determine whether the function is going positive, is increasing or decreasing. So really f prime of x becomes x. And then what do you get? X minus 1 times this other polynomial that you've got there, 2x squared plus 2x minus 1. So in order to analyze this thing, what you need to do is you need to select numbers going from infinity out to wherever, to plus and minus infinity to plus infinity. So the first interval is this guy here, okay? So you pick a number to the left of, what did I say? There was that negative something, negative whatever. You put it in here and you analyze it. Is this function going to be positive or negative? And so I'm just going to hypothesize right now because I don't know what it's going to be. So let's say that this guy is all positive, okay? And then you go from that to this other critical number. Remember, these are called critical numbers. And you select a number here, and let's say that number is -1. So if you do -1, you put it in there, that becomes a -2, and then this becomes a 2, this becomes a -2 or -1, which is equal to -2, and then this is also negative. So this quantity is going to be negative, so this is also positive, okay? Then pick another number from, so this is not a critical number, okay? 0 is not a critical number. So then you pick another number from 1 to this other critical number that you have, which is out here, okay? And see what the signs are. So let's hypothesize that the signs go like this, okay? That you've got, and I'm not doing the whole thing, you need to fill it in, and then let's test whether this is working or not, meaning that this video thing is working or not. So let's say that this is plus, then let's say this is minus and a minus. So if you want to look at the increasing, decreasing, then you write the intervals where fx is increasing. So everywhere you have plus, it's an increasing function. So you got minus infinity to whatever this number here is, which is 1, okay? And then from 1 out, it's decreasing, so it's going to be 1. Sorry, take that back. What does it go? It goes 1 to infinity, okay? So that tells you. And then concave up and down, this comes from the analysis of the second derivative, okay? I'm going to just say this part, try and email it to you, and then see if I can continue with the second part, okay? All right, let's see if I can stop this.